Alright guys, welcome to this page of the notes, and again, what we're going to do here is a couple more example problems using the property of equality for exponential functions. And remember, your goal is to get the bases to be the same, because once the bases are the same, then we can set the exponents equal to each other. So let's just go ahead and do a couple of these, see how they go. And also, if you feel fairly confident with this, please work ahead, come on back, check your answers just to make sure you did it right, because you'll catch on to this pretty quickly. I take a look at this. I have a 9 and a 3, not the same base, but I know, hang on, I can rewrite the 9 as a 3 squared. Again, I don't have to do it to both sides because I haven't actually multiplied, added, subtracted, or divided anything. All I did was take that 9 and I rewrote it as a 3 squared. I put it in parentheses so that I know that that's supposed to be my 9. That's my new base. I've just rewritten it. It's, sorry, not a new base. I've just rewritten my base. And on the other side, I still have a 3 raised to the 6x power. All right, now what I'm going to do is, because I have a power of a power, I'll need to multiply those guys together, but please be careful. This is the first time we've seen this. My power is a 2x minus 1. That is a quantity. In fact, if you want to, anytime you see a quantity as an exponent, if you want to just put it in parentheses, if the parentheses help you to remember that you'll need to distribute the power of 2 through the parentheses, right? And I need to multiply everybody by 2 when I multiply those powers. Essentially, here's what I'm doing. I'm taking 2 and I'm multiplying it by 2x minus 1. And of course, if I wrote it like that, you'd be like, oh yeah, I got to distribute the 2. Well, same thing here. It's just written a little different because I have a power of a power. But remember, power of a power means you multiply the exponents. And in this case, you'll need to distribute. So don't forget to do that. So now I have a 3 to the 4x minus 2 is equal to 3 to the 6x. Well, now we're in really good shape. I have the exact same base, so all I need to do is set the exponents equal to each other. So since the bases are the same, then I know 4x minus 2 is equal to 6x. All right, let's solve for x. I will subtract the 4x to the other side. I get negative 2 is equal to 6x minus 4x, which is going to be negative 2, is equal to 2x. Divide the 2 to the other side, and I get x is equal to a negative 1. All right, and the problems are, again, they're just that simple. Once you get the bases the same, and you'll have to do a little work to get them to be the same, but once those bases are the same, then you go ahead and take care of any properties of exponents you may need to take care of, which will be multiplying exponents. But once those bases are the same, you'll just then set the exponents equal to each other. I got a bunch more example problems here. Let's run through a couple more just to make sure that you guys have got this down. 4 and 64. Well, again, I know I can rewrite a 64 as a 4 to the third power. So I'll have 4 to the 2n minus 1 is equal to 4 to the third power, right? 4 to the third power. Well, my bases are the same. I don't have any properties of exponents I need to take care of here. I don't have any powers of powers, so there's nothing to multiply. I'll just simply go, since the bases are the same, then I know 2n minus 1 has to be equal to 3. I got to set those exponents equal to each other, and we'll solve for n. Add the 1 to the other side, and we'll get n is equal to 2. All right? Got a couple more here. Let's see how the rest of these go. Okay, I've got a 5 and a 125. Well, hopefully you pretty quickly recognize that I can rewrite the 125 as a 5 cubed. So I will have 5 to the 5x power. And what I'm going to do is, I think you'll be okay with this, right? Think about this for a second. If I write 125 as 5 cubed, but it's already raised to the x plus 2 power, right? What I'm going to have to do is multiply my exponents, and I'll multiply 3 by x plus 2. But I'll have to distribute the 3 through the x plus 2. So hopefully you're okay with this. At least you can picture it in your head at this point. We've done enough of these. You should be able to jump straight to 3x plus 6. Should be able to. Again, just because I've rewritten the 125 as a 5 cubed, but that cubed will get multiplied by the power that's already there, the x plus 2. So anyway, again, if you didn't quite see that or you don't see that, I'll write it out because there's no reason not to here. So it would be a 5 to the 5x is equal to 5 cubed times x plus 2, because I've rewritten the 125 as a 5 cubed, but then I got to multiply the power that's already there, distribute the 3. And so anyway, what I wind up with then is 5x is equal to 3x plus 6. I'll subtract the 3x to the other side. That gives me 2x is equal to 6, and so x is equal to 3. Right? I've solved for my variable in this exponential equation. All right, got a couple more here for us. Let's see how these go. 81. How can I rewrite an 81? Well, 81 can be rewritten as a 3 to the 4th power. So this will be 3 to the 2n plus 1 is equal to 3 to the 4th. Well, now my bases are the same, so we'll just simply rewrite this so that our exponents are equal to each other, because that's what the property of equality says for exponential equations. I'll subtract the 1 to the other side. Not a mistake. You are going to wind up with a fraction in this case, and don't let that freak you out or fool you. That's perfectly okay. This is Algebra 2, and getting rational numbers, fractions, as your answer will absolutely happen. Don't let that surprise you. It'll happen. So last one here I've got. We're going to see if we can get this guy. I need the same base. But I take a look at this one, I think about it for a second, and there's no way to rewrite an 8 as a 4, right? Because 4 squared is 16. And I need an 8. So this is one of those ones where I told you you may need to change 1, which we've done, change one of the bases, or you may need to change both of the bases. And this is a great example of where you will need to change both of the bases. Actually, what I'm going to need to do is change both of these guys into a 2. So 4 can be rewritten as a 2 squared, which is raised to the 2x power. And the 8 can be rewritten as a 2 cubed. Well, now I'm going to have my same base, but my base is going to be a 2 rather than a 4 or an 8. I had to go to an even smaller base for both of them. And that'll totally happen. Just watch out for that. If you take a look and you go, well, there isn't any simple way to change one of them, you might need to change both of them. Again, I'll need to multiply my exponents together. This is a quantity, so don't forget to distribute that 3. So I'll have 2 raised to the 4x is equal to 2 raised to the 3x minus 3. I distribute the 3 to the x and the minus 1. My bases are the same, so then I can set the exponents equal to each other. I'll subtract the 3 to the other side. That's going to leave me with an x equals minus 3. All right, guys, hopefully you feel real comfortable now with solving exponential equations where your variable is in the exponent position. And the way that we're going to solve these guys is you just need to get the bases to be the same, and then you'll be able to set the exponents equal to each other, which will allow you to solve for the variable. All right, I got a word problem for you guys, a couple of ways to write exponential equations. So instead of me giving you the exponential equation, we'll work on writing them. That'll be on the next page of the notes, so head on over and I'll meet you guys there.